The next transformation we're going to be focusing on is the reflection. Reflection, remember, is basically a flip. And a reflection is a transformation that flips a figure across a given line. And that line is often referred to as the line of reflection. And that line of reflection is going to be the rule that we're using when we flip our figures in the coordinate plane or in general. So if you take a look at this example 1, I've got two diagrams for you. One's already got the completed transformation. And just remembering some vocabulary, remember if we have B, U, G, this is our preimage, compared to the B prime, U prime, G prime, which is the image, right? The before and the after. Now this segment in the middle, or this line in the middle, that kind of, cuts the two figures in half, that distance in half, is called the line of reflection. And how it works is it, again, cuts the distance between the preimage and image in half. So these distances from B to that line of reflection and from the line of reflection to B prime should be congruent, right? Same for U to that line and the line to U prime. And then finally G to the line of reflection and the line of reflection to G prime. These should be congruent, and that's how you know you have a reflection. It's the idea of mirroring, right? We want to be the same distance but on the other side. So if you take a look at this second triangle BUG, if I wanted to sketch out this transformation without using my ruler, just doing a rough sketch of this, how would I do that? Well, remember what you want to do is you want to think equidistant, right? So what I would do is I would think, all right, if G is approximately that distance away, I want to flip it to the other side, right? And, oops, that's G prime. That same length, right? So again, if B to this line of reflection is, half a centimeter, then I want to go half a centimeter the opposite direction. So I want to start from that line and then keep going. So then B prime would be about here, right? So I'm just, again, estimating and giving a rough sketch. U to U prime, same deal. Like that's about, 3/4 of an inch. Then I want to make sure I'm maintaining that same distance and this going, that same direction away from that line of reflection. So then that's how you create, this image. All right, so I'm going to show you how to do patty paper reflections in class. Remember, patty paper is just another way of creating this transformation. It's another way of constructing, aside from using, our regular compass and straight edge. And we'll do that in class. But let's go ahead and skip this whole section and talk about the coordinate rules for reflection. So just like where we had a translation rule that you could have used with arrow notation or with the vector, we've got rules for the coordinate plane. And before we talk about the rules, let's actually look down at example 2, and I want to show you how to do reflections if you don't know a rule. And I like doing this first because if you just don't remember the rule, or you lost your note card before a test day or whatever, you can always perform the transformation for the reflection just by counting. Count and flip. That's all you need to do. So if I'm looking at A, which is over here at 0, -2, and I want to reflect it across the x-axis, all I need to do is identify where that x-axis is. All right, so I'm going to highlight this in green, and then I'm going to count and flip. So I want to think, how far away is A from that green highlighted axis? Well, it's 1, 2 spaces away. So what I want to do is I want to keep going that same direction and go the same number of spaces. So that's 2 and 2. So this is where A prime would be, right? So if A was at 0, -2, then if I go across the x-axis, A prime is at 0, +2. And that's all you need to do, right? Identify the line of reflection, count, and flip, okay? So if we take a look at B, number 2, I want to take B and reflect it across the y-axis, and I'm going to highlight the y-axis here in yellow. So this is my y-axis, all right? And again, I want to go towards that line of reflection and then flip it over. So B is 1, 2, 3, 4, 5 spaces away from that yellow line. Now I want to keep going 1, 2, 3, 4, 5 away. And then that becomes the location of B prime. So if B was at -5, 1, B prime is at 5, 1. All right? And again, I like this whole idea of counting and flipping because there isn't always a pretty rule for everything. So I'm only going to give you 4 rules, right? X-axis, y-axis, y equals x, and y equals -x. But what if you come across, for example, x equals -3? I'm going to go ahead and erase this so I have a clean slate to work with now. But with y equals -3, you might, or x equals -3, you might be saying, hey, Ms. Huang, there's no rule here, so what do we do? Well, then I'm going to tell you, no big deal. Find the line x equals -3. So we know this is going to be a vertical line where x is -3. So I'm just going to go ahead and highlight this. So this is my line of reflection. I know I'm reflecting C. So let's take that point C, wherever it is, go towards the line of reflection. So this time I'm going to go to the left, 1, and keep going now the exact same number of spaces on the other side. So there's my C prime. So if C was at -2, 3, C prime across the line y x equals -3 is going to be at -4, 3. See? So you can always go back to just the idea of reflection, okay? Finally, let's go ahead and reflect. Let's actually not reflect D because D ends up being on the line of reflection, and if you're on the line of reflection, it doesn't move, which is perfectly fine because some people don't actually realize that. So let me just go ahead and draw in y equals x real fast. So y equals x is this line right here, right? The slanted line that I'm highlighting here in orange. And again, if I wanted to flip D, see how D is on that line? Then it's actually not going to move because it's 0 spaces away, so it's going to stay exactly the same spot. So for the interest of, for the sake of actually doing, flipping a point, let's actually not do D and let's look at B. And you might be thinking, well, how do I reflect something across a slanted line? If it's horizontal or vertical, it's actually super easy. How do I count this distance? Well, you don't actually want to count the diagonal squares. What you want to do is you want to think slope. And what's cool about this is you can actually use multiple points on that orange line to reflect. So all you have to do is take that B and make it to that line of reflection. So for example, I can go down 1, 2, 3 and go over 1, 2, 3, right? And then to do the reflection, what I want to do is do the opposite. So I went across 3, so now I'm going to go down 1, 2, 3, and then across 1, 2, 3. And this would be the point B prime, which is at 1, -5. So B was at -5, 1, and B prime is at 1, -5. Now what I was saying about if you want to use different points is, if I didn't want to go down 3 and over 3, so let me just erase that real fast, we can still get to this point by, for example, going down 1, 2, and across 1, 2, 3, 4. Now again, what you want to do is the opposite. My rise is 2, my run is 4, so now I want to make my rise 4 down, right? 1, 2, 3, 4, and then 1, 2 across. So lots of different ways to do it, but what you want to think is think slope and then think opposite, okay? So now let's talk about the rules. So obviously you can count and flip, but sometimes it's just not that worth it, especially if you're dealing with a large number and you don't have a big coordinate plane. So what are these rules? Well, you might have noticed some pattern here, right? So across the x-axis, we started at 0, -2, and then we went up to 0, +2. So what happens is x stayed the same, and then y became the opposite. And again, think negative as opposite, not, we're keeping the number negative. So it's the opposite of y. Across the y-axis, notice how the x switched signs, but the y stayed the same. So it's opposite x, y. And again, the negative represents the word opposite, not negative number. Okay? And then when we reflected across the line y equals x, you'll see we flipped the order, right? This turned from -5, 1 to 1, -5. So that became y comma x. We just flipped it. The one we didn't do, y equals -x, is when you flip it and you also make the numbers the opposite. So it becomes the opposite of y, comma, the opposite of x. And again, the negatives represent the word opposite. Every year I have people thinking, doesn't that mean it has to say negative? No, it doesn't. It means it's the opposite of that number. So if it's negative, it turns positive, positive turns negative. All right, let's take a look at the U-try problem, and let's reflect these triangles. And you are welcome to either count and flip or use the rules. It's up to you. So what I do recommend you do is graph the preimage. I do want you to graph the preimage and the image, so that way we can see the whole transformation, but make sure you label your points, because we do want to know what the preimage versus the image is. You don't want to leave it up to me to decide, because then I'll say you didn't tell me, so, you know, tough luck. So let's go ahead and graph the triangles. So I went ahead and just graphed the preimage for all three. Make sure, again, you label those points, because I do want to know the difference. You can't just put figures on there and expect me to know. And the other thing I recommend you do is you actually write down the points, the coordinates, because you may not believe me, but every year I get someone who just messes up on the graph, and I don't know if you messed up because you messed up really and you didn't know what you're doing, or if you just miscounted. So that's where using the rules is kind of nice, or just writing down what your points should be on the side are. So for example, if I'm doing the x-axis reflection, I know that rule is x negative y, right? This keep the x and the opposite of y. So a prime, using the rule, what's wrong with my pen? There we go. A prime should be at the point -3, -4, right? So I know I'm going to plot my a prime right down here. You could also count and flip. So if you see how we're going across the x-axis right here in red, I want to flip b down 1, and again 1 more. So b prime should be at the point 0, -1. And again, this is what I recommend you do. You list out the coordinates so that way I can see what you're thinking. Right? If I use my rule, c is going to keep x the same, do the opposite of y, so that's a -3. So 2, -3. Labeling that C prime, there's my beautiful reflection. Okay? Remember, your reflection doesn't have to be two distinct shapes. They can overlap. They could be on the line of reflection, so take your time with it. D doesn't have a rule, so if you want to draw on that line of reflection and flip, go for it. Okay? And let's come back and check our answers. Okay, guys, check your points. Come back to class with questions. We're going to finish this off with some patty paper constructions and talk about a glide reflection and symmetry. Thanks for listening.